Welcome back to day 2 of our factoring unit. Today, our goal, given a polynomial, you will be able to simplify it using difference of perfect squares factoring. And we sometimes abbreviate it calling it DOPS, difference of perfect squares. All right, so in this unit, remember, we are talking all about factoring. So factoring, we are simplifying by breaking into smaller parts. Factoring is also finding what to multiply together to get an expression. All right, so for today, we are focusing on difference of perfect squares. All right, so before we go ahead and talk about factoring using difference of perfect squares, let's first review what are some examples of perfect squares. Well, let's think about that. So perfect squares. So think, what is 2 times 2? That would be 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8, 84. 84, my goodness, 64. And then 9 times 9, 81. And 10 times 10 would give us 100. So why are these perfect squares? So let's go ahead. So these are your perfect squares. Oh, I forgot about 1. What is 1 times 1? That would be 1. Okay, so why are these examples of perfect squares? Well, they're examples because you can take the square root of them. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64, 8. The square root of 81 is 9. And the square root of 100 is 10. All right, so that is why they are perfect squares, because you can take the square root of them and it gives you a perfect number. Now, we also have perfect squares for variables. Now, variables are perfect squares if their power is even. So x squared, x to the 4. We could do m to the 6, y to the 8, z to the 10. We could do n to the 12. We could do p to the 14. Because they are even powers, these would also be examples of perfect squares. Now, the reason they are perfect is because we can take the square root of them. So the square root of x squared is x. The square root of x to the 4 is x squared. The square root of m to the 6 is m to the 3rd. The square root of y to the 8 is y to the 4. Are you starting to see how you take the square root of a power? You end up dividing the power by 2. So let's try a couple more. The square root of z to the 10 is z to the 5. The square root of n to the 12 is n to the 6. And last but not least, the square root of p to the 14 is p to the 7th. So you just take the power, when you take the square root of it, you divide it by 2, and now you have your solution. Okay, so now that we know a little bit about your perfect squares, so our perfect squares are the numbers in the highlighted boxes. Now we can learn how to factor using difference of perfect squares. Okay, so the difference of perfect squares, DOPS, is 2 perfect squares separated by subtraction. Remember, subtraction, aka the difference. So when you have a binomial, a squared minus b squared, you can factor it. So remember, breaking it into the 2 parts that multiply. Okay, you're going to take the square root of a squared, which would be a and a. And then you take the square root of b squared, which would be b and b. One gets a plus, one gets a minus. All right, so that's the formula for difference of perfect squares. So let's go ahead and let's try it. So factor each algebraic expression. A to the 8 minus 4. Now remember, this is difference of perfect squares. So first thing you have to do is double check. Do you have a minus? Are you subtracting? Yes. Next, let's take a look. A to the 8th. Is that a perfect square? Well, is it up there? Yep. to the 8th power. Now, is 4 a perfect square? Let's look in our list. Is 4 a perfect square? There it is, yes. So everything is a perfect square and it is subtraction. So that means I can factor using difference of perfect squares. So I'm going to go ahead and draw 2 parentheses. One gets a plus, one gets a minus. So I'm going to go plus and minus. Now I'm going to take the square root of a to the 8th. Okay, so a to the 8th, the square root is a to the 4th. So since a comes first, a is going to go first in the parentheses. A to the 4, a to the 4. Now I'm going to take the square root of 4, and the square root of 4 is 2. So really this is 2 and 2. And voila, ladies and gentlemen, this is our final answer. Okay, now if we wanted to check, we could check this. So check. I'm going to rewrite my answer, and I'm going to multiply it together. So remember, a binomial times a binomial, we're going to have to use long distribution. So a to the 4 times a to the 4, a to the 8. A to the 4 times negative 2 is negative 2a to the 4. 2 times a to the 4 is plus 2a to the 4. And positive 2 times negative 2 is negative 4. Now, when I combine my like terms, I have a negative 2a to the 4 and a positive 2a to the 4. Those are going to cancel. So I get just a to the 8 minus 4. And that matches my original. So it checked. Check. Okay, let's try another one. So everybody take a look at number 2. First off, is it subtraction? Yes. Next, is 9 a perfect square? Is 9 on our list? There it is. Next up, is x squared a perfect square? There it is. It is. So we can use difference of perfect squares. So I'm going to go ahead and draw my parentheses. One gets a plus, one gets a minus. It does not matter which goes first. So this time I'll put a minus and then a plus. Now, we always take it the first number first. So the first number is a 9. The square root of 9 is 3. So we go 3 and 3. Then I'm going to take the square root of x squared, and the square root of x squared is x and x. And with that, we are done. We have solved and factored. Okay, next up, let's take a look at number 3. So let's take a look first. We have 16. Is 16 on your list? Yes, it is. So that's a perfect square. Is a squared a perfect square? So the power of 2. Yep, it's right there. B squared. So power of 2. Yes, it's a perfect square. And it is subtraction. So I can set this up with my 2 sets of parentheses. One gets a plus. One gets a minus. Now we take the square root of the first term. 16a squared. So the square root of 16 is 4. The square root of a squared is just a. So 4a and 4a. Now I take the square root of b squared. The square root of b squared is just b. B and b. And that is our final answer. So we have just factored into its smaller parts. And if we were to multiply these back together, it would give us the original answer. Okay, so let's go ahead, let's flip the page over, and let's try a couple more. So next up, number 4. So is it subtraction? Yes. D to the 6, is that a perfect square? It's an even power. Is 4 a perfect square? Yes. And is the power of 10 a perfect square? Yes. So that means we can use difference of perfect squares factoring. One gets a plus, one gets a minus. Okay, now I'm going to take the square root of d to the 6. So d to the 6, so remember, if it's a power of 6, you're going to divide the exponent by 2, so that's going to give us a 3. D to the 3, d to the 3. Now I'm going to take the square root of the second term. So the square root of 4 is 2. The square root of c to the 10 is c to the 5. So 2c to the 5. 2c to the 5. And with that, we have factored our binomial. Okay, let's try another one. So let's take a look at number 5. So is it subtraction? Yes. Is 81 a perfect square? Yes. Is y to the 8 a perfect square? Yep. And is 1/4 a perfect square? Well, let's say you are not sure. We can check it in the calculator. So in the calculator, I'm going to go ahead and I'm going to type in the square root. So that's here. So blue square root. And I'm going to put the square root of 1/4, 1 divided by 4. I'm going to hit enter, and we get 0.5. Now, if I hit math fraction, I can turn that back into a fraction, and I get 1/2. So is 1/4 a perfect square? Yes, you can square root it, and you get 1/2. All right, so let's go ahead and let's factor this out. 1 gets a plus, 1 gets a minus. I'm going to do my minus first this time. And I'm going to take the square root of 81a to the 8th. So the square root of 81 is 9. The square root of y to the 8 is y to the 4. So those stay together because they are together as one monomial. And then 9y to the 4 is the first term in the second binomial. And then we take the square root of 1/4. Remember, we just did that in the calculators. The square root of 1/4 is 1/2. And ladies and gentlemen, you have just factored your next binomial. Okay, one final one left. I'm going to have you try number 6 on your own, so go ahead, pause the video, and give this a try. All right, let's go ahead and take a look. Did you get 5 plus s squared and then 5 minus s squared? All right, remember, since the 25 came first, the 5 has to go first. The s is second, so the s has to go second, and we've got it. All right, one final question for today, number 7. The area of a rectangle can be expressed as the binomial t squared minus 49. Express the area as the product of two binomials. Hint, what are the length and the width? So let's take a look. It's the area of a rectangle, so let's think. What's the formula for an area of a rectangle? That is area equals length times width. Oh wait, so they told us the binomial is t squared minus 49. So I want to break that into two things that will multiply together to get t squared minus 49. Okay, well, let's think. To break this into its two smaller parts that multiply together, I can use either GCF or difference of perfect squares. We always want to try GCF first. So is there a GCF between t squared and 49? Nope. So now let's try difference of perfect squares. Is t squared a perfect square? Yes. Is 49 a perfect square? Yes. And is it subtraction? Yes. So that means we can use difference of perfect squares to break this into its two parts. So I'm going to go ahead, give one of these parentheses a plus, give one of them a minus, and then I take the square root of t squared, which is t, and then I take the square root of 49, which is 7, and 7. And with that, we have just broken down the area into a length and a width. So my rectangle would look like this, and I could have t plus 7, t minus 7, or let's say it was actually a tall and skinny one because it didn't specify which is the length or the width. This could be t minus 7, and this could be t plus 7. All right, ladies and gentlemen, great job today with being able to factor using difference of perfect squares. So make sure you always have your two lists ready to go. Great job.